You're listening to Power Athlete Radio, a podcast dedicated to empowering your performance every damn day. Join former NFL pro and Power Athlete founder John Welborn as he dissects the greatest minds in strength, conditioning, and more. So whether your goal is to be the hammer, destroy mediocrity, or simply move the dirt, you've come to the right place. Now with the warm-up done, let the gains begin.
Hey, Power Athlete Nation. Welcome back to the premier podcast in strength and conditioning, Power Athlete Radio. And I'm joined by Lauren Fritsch. Fritsch? Fritsch. All right, fuck. We even prepped it ahead of time, and I still messed it up. Lauren Fritsch from New Amsterdam Genomics. And just for a little bit of transparency, I became a client and really just a patient of you guys in 2017 through Dr. Tom at Causenta. The way he put it in, he's like, hey, we're going to do this genetic test that's a lot like an annuity. You're going to put in once and you're going to be able to get information for as long as they're in business. And I thought that was much more interesting, more so than just giving your genetics and getting some printout sheet where they're like, oh, you should be an athlete. Oh, you should eat chicken, which is really what I had seen up until that point. And so I didn't put a lot of stock in really the genetic stuff and just the fact that the way that people were spinning it as if this is the new frontier. We're going to be able to tell you everything about you from your genetics. But unfortunately, here we are almost 10 years later, and I feel like that narrative has really changed.
Yeah, absolutely. Dr. Tom's a great guy, so I'm really glad that you get to work with him.
Yeah, no, he's I've known him for, almost over 20 years. So I met Tom in the early 2000s when I was a young NFL player and went to his house. He didn't even have a lab or an office at that point. He took something like 40 vials of blood from me in his kitchen. Oh my gosh. Like I walked in, the entire place was covered in like supplements. Like there was no cabinet space. Or like not even any counter space. It was just hundreds of bottles of weird supplements that were all like half open. Some were open, some were empty. I like walked in and I almost had a little bit of a panic attack because I like things to be neat and organized, and his was anything but. And so then he sits down at his kitchen table and just starts taking blood vials off me. And I'm like, what is this? This guy's like a vampire. He's taking so much blood. So, and then he, a few weeks later sent me this encyclopedia of all of my blood work. And it was this comprehensive. And I've worked with Tom, gone and seen him twice a year since the early 2002, 2003, I think. So it's been 20 years. So I have a pretty amazing, history. And so whenever anything comes up like your guys' service and what you guys are doing, to see him be an early adopter is really all I need. Because at this point, I figure I'm already on Dr. Tom's train. Let's see where it goes.
Yeah, no part of that story surprises me.
It's funny. I've told that story before, and anybody that knows Dr. Tom is not surprised by that story either.
Yeah.
So for people that do DNA tests, and like most of the DNA tests that I've come across are like ancestry tests, where it's, your family's from this part of the world, here's your genetics, and there's really just kind of giving you these overviews of places that like predictions where your parents are from. Like how is New Amsterdam Genomics different?
So completely different. So you have roughly in the ballpark of 22,000 genes. There's a lot of information across 22,000 genes. So some tests will look at things like ancestry. Now, if you want to find, your long lost cousin from some faraway place, you can absolutely do that with DNA. It's actually relatively straightforward because what we're looking for in the DNA for something like ancestry is going to be a common mutation. That's the whole point, right? If we take a bunch of people in one area, they should all have similar genetic markers. That indicates they're from the same place. So you're looking for common things. Pretty easy to do. Not really the case when it comes to health data. And that's really where New Amsterdam Genomics is focused. We do clinical grade sequencing for clinicians. So we don't really care where our patients came from. That might be interesting for them, but we're really focused on how can we transform healthcare. When we talk about health-related genetic variants, by their very nature, those tend to be much more unique. Otherwise, we would expect every patient walking into a doctor's office to have all of the same problems, or we could kind of group them into buckets in the same way that we do for ancestry. So still looking at the genetics, just completely separate types of mutations that we're looking for.
So with those different mutations, you basically take those mutations and you plug them into, some advanced learning model, some form of AI. And then what it does is it links you with the current research at that point associated with that genetic variation or something within the genes?
Yeah, so in essence, what we're doing is we're using a sequencing as opposed to the kind of genotyping style of test you'd get with like a 23andMe or similar test. So you start out with a lot more information, and this is gigabytes of data. And that's not possible for one person to go through for every single patient. There's just no way. That makes no sense. So what we do that's really different is we have a proprietary AI model that's actually comparing every mutation a patient has with all of the medical literature. So in other words, it's looking through if you've got, 10 million different mutations in your DNA, it's going to compare each of those 10 million mutations to every paper that's come out, every database that catalogs these different pathogenic mutations, things like that to really look for, well, what does this actually mean in context? And the nice thing with that approach is it's easy to find stuff that's very common, right? That's what we talked about for the ancestry. You can do the same thing for health data. But we can also look for very, very rare 1 in a million mutations and use that algorithm to actually help explain these very rare things where maybe there's not a whole lot of data supporting what that mutation means, but we can compare that mutation to similar mutations, kind of extrapolate beyond just that known literature and say, well, here's what we think this means, with the caveat that, the science isn't super clear cut, but it gives you and your healthcare team access to literally the most cutting edge medicine available because we can really use that AI to look at, how is the science changing? What does this mean now? Not what did it mean 2 weeks ago?
We interrupt this episode with a shameless self-promotion. Power Athlete delivers battle-tested performance programming for every kind of athlete. So do you want to go from average Joe to MVP? Then dominate with Field Strong. Get stacked and jacked with Jack Street. Hustle in life and still build muscle with Grindstone. Fear no opponent with Dragon Slayer. Be harder than coffin nails with Hammer. Max out minimal equipment with Lean Enable. Or unlock those newbie gains with Bedrock. Get over to powerathletehq.com/training and choose your 7-day free trial right here, right now. Get lifting, get training, get in shape, all while listening to the rest of this show. Well, and over the course of, since I started in 17, we're talking, what's that, 8 years, I've seen this constant evolution of the back end and more importantly, the reports that I'm getting. So I try to, I set a calendar reminder about every 3 or 4 months. I click through and I look at updates, and it's been pretty fascinating because you show risks, and then there's also this little circle, which is how much this affects you. And if the circle's complete, it's 100%. If it's half, obviously 50. So I've seen things that were 50% go to 70%. I've seen things that have been 100 go to this. And so it's fascinating that the model is like a living, breathing report where now all of a sudden there was one paper, 7, 8 years ago, and now all of a sudden I have 30 papers. And so it's almost this collaborative method. And things that were risks 7, 8 years ago, now are no longer risks. And it's really just kind of fascinating to go through. And I was very fortunate in that we had my dad, before he passed away, that we had his DNA sequenced. I have my son and I have my wife, so I have 4. So I'm able to see 3 generations, and then also the contributor to my son. I haven't done it for my daughters, but I haven't told them. They'd probably be mad that they don't have it. But I think that at least when my dad was sick, Dr. Tom was very focused on we need to get your dad's genetics done just for your history and your kid's history. To be able to have 3 generations would be extremely valuable.
Yeah, absolutely. And you kind of hit the nail on the head there with the real advantage in doing this sequencing approach is the science is always changing. So I think a lot of times people think about science as this very, black and white thing where we do a study, we have an answer, and now that's the answer, and we can, write it in stone and we've got it forever. But that's just not the way that science works. It's constantly an evolving process. Sometimes we're limited by the tools that we have right now, but maybe, a few months from now, we develop a new test, a new way of assessing something that completely changes our understanding of the biology. So one of the really important values for us is not to give you information that's useful based on the current science, but to give you information that can constantly be evolving alongside that science. So that's why you'll see things on your report where new studies come out and we're more confident in it. Or maybe there's a study that comes out and says, yeah, this previous study, maybe they didn't use the right control group for this, or maybe there's a new test available that really kind of nullifies those previous results. We're really not so confident in this anymore. Let's take it off. So it really gives you and your healthcare team the option to look at the science as it evolves over time, especially in your case where you've got multiple generations. So you can really see how those things change.
This episode of Power Athlete Radio is powered by Train Heroic, the most immersive strength training app experience on the market. We've built an online training business by partnering with Train Heroic to deliver all of our world-class training programs like Jack Street, Hammer, Field Strong, and Grindstone. To learn which Power Athlete training program best suits your goals, head to powerathletehq.com/training. And if you're a coach looking to build a business with the best training tech in the business, head to trainheroic.com/powerathletehq. And now back to the show. One of the things that always jumps out at me is the amount of things for my dad is kind of small. And then I'm a little bit bigger. And then my son is obviously bigger. So it's almost as if each generation is having more mutations. And that is kind of an interesting thing to kind of wrestle with a little bit. Is it the fact that, environmental toxins and all these other extraneous factors that maybe my dad didn't necessarily, expose as a child of the Depression, being born in the, mid to late 1930s, opposed to me born in the 70s and my son's born obviously after 2000. So it's kind of, it just always strikes me when I click on it. My dad's like just here and everything seems to get a little bit bigger. I'm more interested to see like if we're able to keep this going and my son ends up, or my daughters have kids, what they end up seeing.
Well, and so this is going to be your germline DNA. So this is the DNA that shouldn't change over time, which is an important point to make because these aren't things that we should kind of add to or subtract from. The mutations you have are the mutations you have. What changes, though, is our interpretation of them. So you can imagine that, someone that did a test 10 years ago when the company first started out, their list was probably pretty darn short because we didn't know as much as we know now. And now that list might be longer for them. It might not be the exact same things on there, but it might be a longer or shorter list, just depending on what they started out with. But in terms of, how this ends up being passed on, what can be actually really fascinating is, especially when you have families, looking at, well, which side of the family did this trait come from, and kind of explaining things out that way. A little bit of a tangent, but I actually have on my own report a risk for AFib, atrial fibrillation. And my father has AFib, so I kind of assumed that was coming from that side. Well, when my mom did her test, it was actually from her side, which completely changed the way that I thought about the interpretation for this, because I know she doesn't currently have AFib. So in theory, there's probably another AFib gene out there that we just don't know about yet, that in theory, there's, a 50-50 chance I've got that too. So again, kind of a tangent, but it's really fascinating when you look at multiple family members just to tease apart, well, who had this mutation? Where did it come from? Does that actually track with the family history? Well,
my dad passed away 7 years ago. So we got his genetics done before he passed away. So obviously, he lived to be 80. And so some of the health issues that he had through his course of his life, I can see play out in the genetics. Like one of them was thrombosis. So he had, what are they called? Varicose veins in his lower legs. And that was something he had through his entire life and had to go in and have surgery where I think they went in and like either they removed them or they collapsed them in some way because he didn't like them. So that was something that he had, and he always blamed it on, so he was a lawyer in Southern California, and he drove around all the different courts. So he always blamed these veins and these kind of engorged veins on the fact that he was driving everywhere, pushing a clutch, and then also have to wear high socks. So it was the socks, the pressure, and this. And he's always like, oh man, I have these different veins associated with this. And then as I'm looking at his genetics, like that was one of his predispositions. I mean, he had a genetic trait associated with that, whereas I've never had it and my brothers don't have it. And so the other one, like, he ended up having, prostate cancer, and then he ended up dying of cancer. So it's pretty interesting, like looking at some of his health issues that I know. And it's funny, I've gone back and like kind of read it to my mom, and he's like, oh yeah, he was that, but he also didn't really exercise, didn't really care what he ate. didn't take supplements, and was just kind of like lived his life and worked too much and did all these things and ended up making it to 80, which I think is pretty fantastic. But I feel like if he had taken better care of himself, some of these things would not have manifested the way they did. And I think that's the interesting thing with genetics, where people are like, oh, I got this or I don't. I'm like, well, I mean, there's things in my genetics that have never come to fruition that if you look at aren't necessarily the best, most optimal things for what I ended up doing, which was playing in the NFL.
Yeah, and that's a great point, because just because you have a genetic marker for something by no means guarantees that you'll have that condition. So it's something that we refer to as the penetrance of a mutation. There's a handful of diseases that are 100% penetrant, meaning everybody with that mutation goes on to have that disease. There are so few of them, though. Just about every disease, even genetic diseases, have so many factors at play. Many of those factors we don't even understand right now. So realistically, what the genetics is doing is saying, here are all of the possibilities. Maybe there's some other possibilities in there too that are not genetic in nature. You imagine somebody with no genetic risk for obesity that eats terribly. Well, they might still gain weight, even if they don't have the genetic predisposition for it. But the big thing is it's saying, here are all of the things that could happen. And then the goal for our reporting is everybody lives to 100. They look at the report and then they say, man, these guys got it wrong. I don't have any of these things. That's our hope. Our hope isn't to get it right and say, yep, here's everything you've got. It's to say, here's everything that is a possibility for you. Now, here's what you can do to prevent that from coming to fruition. Oh, you've got a risk for, blood clots. Now you can be more aware of things to lower your risk for having a blood clot form, for things that, can for basically the triggers for when might you experience that blood clot. Oh, you're going to go in for surgery, you're going to be on a long plane ride, move around as much as possible, things like that. So it's designed to be very proactive. We don't want you to say, yep, here's everything that you've got and have it, check off on somebody's medical chart.
Yeah. So the system that you guys have developed is really for the clinician and for the doctor. It's not necessarily like a recreational, like something somebody does for fun. It's a little bit more on the other side of that. But there is a individual user interface, but it, obviously it comes with like somebody like a Dr. Tom or somebody that can understand it. And then he works with your team to kind of help him understand. And then you have to be just, I guess, we did a podcast a couple of weeks ago. One of my PhDs that works for us got on here and actually discussed like how to interpret research. And one of the problems that we run into in this world is everybody's like, where's the research? But yet nobody understands how to interpret this research. Can you get into a little bit of like, because it's got to be millions of research papers. How do you guys like sift through that? Like let's say the AI kind of sifts through all these things associated with it. Is there another layer to be able to be like, the controls aren't good, or we don't like the outcome of that one? Like, how do you, instead of just bombarding somebody with everything that's associated with that genotype, let's say, how do you guys kind of sift through that?
So there is that process in some regard. So the big thing is we don't want to add our own biases to this. There's compound that. So a lot of what we're doing is pulling in these papers, linking it to a certain mutation so that you and your doctor can look at it, and then leaving it up to your clinician to kind of dig through that and decide if they think that that's valid. Now, there's some caveats to that. So what this really means is we can't have an AI algorithm that's going to look through and say, these are all of the, good studies, these are the bad studies, and discard things. That wouldn't really be the most ethical way to approach things. But what we can do is in, is this a journal article that was retracted or something like that? Obviously, that's going to then get removed from there. It's also going to look at the number of studies. It's a very simple way of putting things, but you can imagine if there's one study on something, science isn't necessarily that sound or that strong at least. Whereas if there's 10 studies on it, let's say that 2 or 3 of those, they didn't use the right control group or something like that, but all of these papers have still come to the same conclusion. That's going to be a much more compelling case for that, why that mutation is relevant. And the algorithm does factor that in for that impact calculation that you were talking about, where it's looking at things like the amount of science backing a particular finding.
So I think, I'm like, obviously it sounds incredible, but then I know what most people are going to say, like, I can't interpret this research. So, I mean, obviously you need a clinician. Is there any like real world examples of like things that, maybe somebody wasn't, not that I'm asking you to break some, client or patient doctor privilege, but, like I'm always fascinated by like the real world. And that's kind of what I ask Dr. Tom all the time. I'm like, have you ever used this system to assess something that you were able to like, cut off before it necessarily became something or, brought something to light that somebody didn't know that ended up being life-saving?
Yeah, so there's kind of two sides to that coin. So from the patient side, even if you are not a researcher, you're not trained in digging through all of these papers, you can still make use of it. Maybe you're not going to, get the same level of detail that someone like Dr. Tom, who's just absolutely brilliant, is going to get. But that doesn't mean that it's useless information for you. So one of my favorite examples, just because I think everybody can understand this in some way, is people that have risks for obesity. Just because it's on there does not mean that you're going to have obesity. But everybody knows someone, or they themselves are someone who has struggled with weight for a really long time. They exercise regularly, they eat well, and they're just the person that they can't lose those last few pounds. From a patient perspective, knowing why that is, why you might be struggling with it, can be a hugely empowering thing, because you understand that everything in science and everything in your biology is very complex. It's not just that, you need to eat well and you need to exercise. Sometimes people win the genetic lottery and it's just really easy for them to get weight off. And sometimes for people, it's going to be a little bit harder. So you don't need to go read the scientific study to understand why that might be relevant for you. Something as simple as looking at it and saying, oh, okay, this is why I feel hungry all the time. It's not me being lazy. It's not that I don't care about my health. I'm not trying. I get it now. And then it can kind of be that motivating factor to help you with those, last few pounds or whatever the case may be.
Yeah.
So that's the patient. Sorry, go ahead.
Oh, no, go on.
That's the patient side. The doctor side, though, tends to be for things that aren't quite as obvious. Telling someone that they have risk for obesity. For a healthcare provider, well, we can look at a person and say, are they overweight? Are they not overweight? Step on the scale, that kind of thing. Where that becomes really powerful, though, are typically for these less common diseases. So some good examples of this are in the cardiovascular disease space. So you can imagine someone who has a genetic risk for a cardiomyopathy, let's say. Maybe this is a patient who's never done, an echocardiogram or a cardiac MRI or something like that. You have no way of knowing that they potentially have this, fatal disease lying in wait there. So we've seen a lot of clinicians where, especially with younger patients, we've seen younger athletes that do this, and we find out, yeah, they've actually got this risk for cardiomyopathy. Let's look into this now before it becomes a problem. So we have tons of things like that. And then you can also get, even more simple with that, where something like diabetes, maybe you've got a patient where right now their blood sugar control is great, their HbA1c is totally fine, you have no concerns about their diabetes risk. But knowing that they've got 5 different genetic markers that make them more likely to have insulin resistance, maybe you're going to really dial in on some extra labs, and you're going to make a note to look at those more closely and more frequently. And that over time can be really impactful. So you get both those kind of, short term, this is something that, might kill you while you're out on a run. And this is something that, might kill you when you get to 80 because your insulin resistance is so bad.
Some of them are obviously like this, like cardiovascular and, obesity, but then some of them are also like a little bit more, I don't know what you could word, like less severe, where it's like genetic traits for eye color. And, and then also I think that something to tell is that it's not all negative. Like I have a green 100% that I think is associated with nicotine addiction, that I have some gene that prevents me from being addicted to nicotine, which isn't really a big deal because, one, I'm not into nicotine patches or cigarettes, and I'm not a nicotine person. I would much rather drink coffee. So like that stuff was kind of interesting. And then so it's obviously like positive things, but there's also negatives. So when you kind of balance that, and I know what you guys do a great job of is being able to recommend lifestyle changes and also exercise and some of the behavioral modifications that people need to be able to kind of see, and be able to match it. Like, okay, here's this information, here's these negatives. Now, how do I action this in the real world?
Yeah, definitely. So some of those mitigations end up being kind of unusual too, which I think is kind of interesting. So there's a lot of different studies about, types of diets and things like that. And that's somewhere where, you could go through the study and say, yeah, I don't really know if they did this quite the right way, or maybe I don't totally believe this. But a lot of it gets to, are there certain compounds that can be helpful? So I think actually you have a benzene
Yes.
toxicity risk, I think, on your report.
Which is weird because I work on cars
Yeah.
and I don't work on gas cars. I only work on diesel. So like I have diesel trucks. I try to do, so whenever I get around gas, I drive a diesel truck. My wife drives a gas car. She's like, can you put gas in? I'm like very nervous, not nervous, but like I'm very conscious of not getting any gas on my hands. And
Hmm.
before I saw that, like the amount of times we had spilled gas or worked with like some harsh chemicals in the shop and gotten gas on me was probably too many to count. And then as soon as I saw that, I was like, oh, I need to be much more conscious of being exposed to gasoline.
Yeah, and I mean that's something you don't think about that as being a health risk, right? Like when you go pump your gas, you just pump your gas. You don't really think anything of it. But knowing that for some people, that's going to be a bigger deal if you're getting that gasoline on your skin and things like that is really important. But for that particular mutation, it's simple things like we know that sulforaphane that you get in cruciferous veggies like broccoli and cauliflower actually upregulates the production of that protein for you.
Yeah.
So for you, you already eat a healthy diet. It doesn't really make much difference. But you imagine, let's say you've got a mechanic who they're eating what they can between appointments or something like that. They're probably not eating all that much broccoli. And for them, something as simple as, well, eat more broccoli. You're constantly exposed to these hazards. This can be helpful for you is such a simple thing. So it can be these big, a high protein diet's really helpful or something like that, but it can also be, well, here's this particular food that just based on the biochemistry might have helpful things for you.
Well, the other one is most people, and I know they tell you not to do this at the gas station, but I always get back in my car and shut the door. So obviously getting it on your hands is no good, but it's actually the fumes because you think about the lungs like one cell membrane. So your ability to be able to absorb this stuff through the lungs is actually just as toxic. So like that's when you're like pumping gas and those fumes are coming out and people have their like face right there. And I'm always like, oh God. So I like set it up, get back in the car and shut the door. And yeah, I mean, that was, something obviously like you get gas in your hands and you kind of feel like, oh, it's not that big a deal. But after doing that, like I became much more hyper focused on like not getting exposed to the fumes and just, one of those things. But yeah, like I think that's also maybe why I gravitated toward diesels where I'm like, well, if I drive a diesel, I'm not going to get exposed to gasoline in the same way.
Yeah. Well, and that particular mutation too is one that basically it's one of the proteins that helps protect your cells from damage. So that damage can be in the case of something like benzene, it can be other environmental toxins. And if it doesn't work very well, it's something that can cause blood cancers, especially leukemia. So that's something that, it's a minor thing, but over time that can be something potentially very devastating. So like for you, if you're working on cars that, regular exposure can be really problematic. You take that same finding though, and you put it on somebody's report and maybe they don't even own a car, they don't drive, they're never at a gas station, anything like that. They're not around these chemicals. That's kind of a moot finding for them. They don't really care so much about that. So I think that's the other thing that's really interesting with these genetic results is the way that you interpret it is so dependent on the individual person and what their lifestyle looks like, where a finding for one person might be, a complete deal breaker in a hobby or something like that. And for somebody else, they just cross it off. They're not even worried about it.
The other one Dr. Tom recommended was sauna. So, being able to, get into a hot sauna, sweat out these toxins and then get the moisture off your body as fast as possible. So the idea that, a lot of these things linger in the body, but if you can get them out of the body quickly through exercise, sauna and other ways. My joke is we live here in Texas where it's always hot. Like
you don't need a sauna. You've already got one.
No, I live in Texas. It's funny. It was pretty humid today and I took my kids to school and my daughter's like, it's so humid out. I'm like, yeah, but at least the sun's not out. And in about 3 months, this place is going to be like the face of the sun. So like, take it for what it's worth. There's a lot of misconceptions float around with like biohackers and influence over that DNA determines your destiny. But that feels like a lot of bullshit. And one of the reasons that I was excited to bring you guys on and I reached out was that you guys live in what I call the real world a little bit more, and not necessarily that DNA and magic and, this is how you get kind of scammed by these biohackers. Like, was that, like, I don't understand how that kind of took hold, or more importantly, like, it's nice that you guys have that, but like, is it something that you guys kind of encounter where people are looking for some magic silver bullet, or this is the reason? And really it's kind of depends on a lot of different factors. How do you guys balance that?
So I'll preface by saying I am a scientist. I did a PhD, not an MD. So I don't have to explain these things to patients where I say it's this, black or white thing that a patient can understand. So I totally understand when I speak with these clinicians who really want these simple things, why they want it that way. The truth of the matter, though, is science is messy. It's very complex. There are a million different factors to every biological system, some of which we know and some of which we can't even imagine yet. So something that I get all the time is people will say, well, why does it say that the evidence is mixed? Why can't you just give me a clear-cut answer? It's like, well, I know there's tests that they'll give you a clear-cut answer, but there isn't a scientific backing for that. So what it really boils down to is, do you want accurate science or do you want something that's easy to understand? And what we try very hard to do is bridge that gap, where a lot of my job is trying to kind of sift through all of those complex scientific studies and say, here's something that it's not black and white, but it's probably a pretty safe assumption, and it's not something that's going to harm a patient. So it's absolutely a problem where there are these companies that say, yes, you should eat this type of diet. I saw a company that was trying to tell you your exact macronutrient breakdown based on your DNA. And I was like, man, that'd be fantastic, but there's no science for that. You can't even imagine a study that would give you an answer that's that clear cut for every person based on DNA. That's just not possible. So yes, absolutely. People want these things to be super easy to understand, where it says you have this, you're guaranteed to have this disease or something like that. And that is just not the case. It's really, we operate in this area of gray. So then where this is useful is kind of what we had talked about earlier, where what are the possibilities? And it's giving you a narrower list of possibilities rather than saying you're at risk for every disease known to man. Maybe that's still a little bit true, but these are the priorities for you. And it's giving you an area to focus in based on the best science we've got right now. There's no guarantees, but it gives you somewhere to go that's not just, I need to prevent every single disease I could ever have.
One of my favorites is the MTHFR gene, and like Gary Breda and this gene mutation, which I think has to do with folate and B vitamins and not being able to, methylate B vitamins. For some reason, probably because my phone heard me talking to you guys, I've been getting this pitched annoyingly. And he gets up, and I don't know him personally, but the definitive way he speaks in this absolute about this gene, if you have this, you can't do this. Is that something you guys encounter? I mean, how, you guys are a little bit more on the battle of the bullshit, where people are like, well, I have this gene, I have this mutation, so-and-so said this. And you're like, it depends.
Yes. You bring up one of my biggest pet peeves about genetics at the moment. So MTHFR is a real thing. There are genetic variants in this MTHFR gene that influence the enzymatic activity of MTHFR. It is not the end all be all. It does not explain why you have this thing and that thing. About 1 in 3 people have one of the more common mutations in that gene. So I'm not saying that there's no science there, that it's not useful to know about. But imagine anything that 1 in 3 people have. How much does that really tell you about that person? Very little, right? So the more common a mutation is, the smaller the effect on health. That's just the way that it has to shake out, because if everybody has it, it's not going to be a major, deal breaker or anything for a particular disease risk. So something like MTHFR, people like simple, right? Just like we talked about. They want it to be this very clear-cut thing. I don't blame them. I would love for everything to be simple too.
Yeah, it'd be a lot easier if you could just hand me over and hey, here's what you need to do exactly. And that's what people want. They want almost like a direction manual. I mean, you think about the most complex organism on the planet, and it comes with no directions.
Yeah.
So I think that was the idea when it first was pitched. I mean, when they kind of started sequencing the genome, there was this overwhelming kind of early feeling that we're going to be able to give humans an accurate direction manual for themselves that they should just be able to follow based upon this. But, there's 10 times more, bacteria in the body than there are cells, and every gene is influenced by all these different things. And I think it's like a prevailing feeling, especially, now with the rise of social media, that the human body is, everything exists in a vacuum. Like here's these different systems. And even when I was in school, going through, bio and this, like they taught these systems very like siloed, like here's your digestive system, here's this and this. And that's just not the case. I mean, everything is so interdependent.
So one of the reasons I actually opted to go the PhD route instead of the MD route was when I was in undergrad, I had the chance to go sit in on some med school classes. And I was planning on going to med school. That was always the plan. And I wanted to specifically do neuroscience or neurology or something in that vein. So anyway, I go to this class. They're talking about the different parts of the heart and how the heart works. And I'm sitting there diligently taking my notes as an undergrad that's not getting a grade in this class. And we get to the end of the class and I ask the med student that had brought me over, like, okay, so when do we get to ask questions? I want to know how this relates to, and I don't even remember what it was, but this other aspect of biology. She was like, well, no, we don't ask questions. We memorize the information, we take the test, and we get out of med school. And I think that that's something that has kind of prevailed in healthcare right now as we get these silos where everybody thinks, well, I'm a cardiologist, so I study the heart. And they forget, well, your heart pumps blood to the whole body. So it's going to relate to everything. And that's the same way that genetics works, where everybody wants to think about, well, it's just MTHFR. Well, it's not just MTHFR. It's MTHFR and a million and one other things. And we want to make it simple and segmented and look at these things in these buckets. And we've kind of forgotten to look at the whole human body and the entirety of the genome. And that's something that I'm very fortunate in this job. I get to work with some of the top doctors around the world where they are starting to have that shift and they're looking at things more holistically. But it's a huge problem where, you ask a patient, you've got an issue with your heart, where do you go? Well, the cardiologist, of course, that's where I would go, and it seems so intuitive, it seems so logical, but everything is way more connected than we would like to think. So I think that's one of the biggest pitfalls we've got is looking at everything as if it's its own system and there's just this one system in isolation when it connects to everything else.
What about like medications? Like, we've kind of talked about lifestyle changes and early screenings and how like the genes and the reports can potentially give clinicians an idea of like what they need to be looking out for. But one of the ones that's fascinating is to know whether or not you have a genetic, I guess, mutation or whatnot that prevents certain drugs to work and then others to work. I thought that was a really fascinating piece.
So you're talking about something called pharmacogenetics or pharmacogenomics, and that's referring to how we would expect someone to break down medication based on their DNA. Now, there's other factors that go into prescribing a medication for someone other than just the DNA, just like with everything else in biology. But what this can be really powerful for is looking at different mutations that maybe change how well a protein that breaks down a certain compound works. And you can imagine if you change that breakdown process, it can allow a drug to build up in the system, or maybe you break something down so quickly that that medication doesn't actually have time to be effective in the body. So we have a full pharmacogenomic analysis that looks at all of the different guidelines that are available, dozens and dozens and dozens of different genes that relate to drug metabolism to help doctors figure out where to start for a medication. That doesn't mean that we can say, here's the exact drug that this patient needs, and if you give them this dose, it's going to work perfectly. They'll never have a side effect. Again, I wish it was that simple. But what we can do is say, this is probably not the best drug to start with. These are some better options, or cross this off your list. And, maybe you need to switch to a different class of medication because the way that this entire class is broken down, it's just not likely to work super well for a patient. So it's not a magic bullet. It's not going to give you the exact answer that you need, but it can be really helpful, especially for someone that is sensitive to medications, or who maybe it's somebody that they really are kind of averse to taking a medication for something and they want to take the lowest dose possible. If you know there's a medication that's more likely to work well for you, so you can take a low dose, you should absolutely start with that instead of needing to, max out the dose of something else.
So but that obviously would come with a recommendation from the doctor, right? So like you guys are working with a clinician being like, hey, I wouldn't max this thing out. Like, let's be a little smarter on this.
Exactly. So we don't give patients any medication recommendations. We can't do that in any way, shape, or form. We don't know their medical history. Maybe they've got an allergy to something that we don't know about. So we're never going to say to a patient, this is the medication you take. And in fact, those medication tools are actually only available on the clinician view of the web portal.
Yeah.
But for the doctor, they can run a panel of meds, they can look up a specific medication, and then they can compare and say, well, I was already thinking about this medication. Based on the patient's genetics, I see no red flags. Let's go ahead and start with this. So yeah, it always has to go through the healthcare team that's familiar with the patient's actual labs and health history.
So obviously the role of the doctor is very important in this process, right? Like being able to take this information and make decisions for the end user with you guys kind of going in. Is the interaction with the doctors, I guess it's only limited by how, I don't want to say intelligent, but like how curious the doctor is. Because I've run into some doctors that just feel like they want to paint everything with one brush. Like, oh, everybody like this, everybody here, your cholesterol's a little high. It's very easy just to paint these pictures. So how do you guys work with doctors to kind of understand like the nuance that everybody's in a slightly different position?
The biggest thing is it's up to the doctor. So you get guys like Dr. Tom, where he will happily go down the rabbit holes of everything. And, one of the last times I met with him, I think we went out for a dinner and we chatted for probably 4 hours because he will talk about every aspect of biology in depth. You can chat about anything with him, right? Yeah. He wants those details. Yeah. So for me as a scientist, I will geek out with other fellow nerds all day long and talk about all of these details.
Well, he, for laymen that don't know Dr. Tom, there's always a feeling of like, this guy has to be full of shit for the mere fact that his knowledge is so deep, but the fact that you're a PhD and this is what you do for a living and you're actually co-signing, kind of a little piece of me dies because I accuse him all the time of bullshit. I'm like, Doc, there's no way you know this, but like his knowledge base is so deep. It's sometimes like, it's like, dude, there's no way you learn this much stuff, but this is what he does.
Mm-hmm. Yeah, he's a brilliant guy. So we get the doctors like him where there's no way I'm ever going to know as much as he knows, right? Like, it's just, I don't know how he does it.
Well, so, he's done blood testing on more humans than anybody else on the planet. Like it's pretty accurate. Like he's made that kind of assertion mm-hmm. a few times. And then he goes to show, he's literally done blood testing on like hundreds of thousands of people and not just one, but like infinite amounts of blood testing. So my wife and I go see Dr. Tom, and my wife's gone and seen other doctors. And when she presents her like Dr. Tom medical history, like their eyes go cross-eyed and they were like, what is all this? Why would somebody have done this much testing? And it's just, that's his deal. Like, I'm going to test everything and we're going to figure out because we never know what's going to be the deciding factor.
Yeah. Yeah. He showed me a couple of his spreadsheets on all of his different workups and it just blows my mind every time. But anyway, so we get the guys like him where he wants all of the details and more. Then you get other doctors where, not that they aren't curious, but maybe for time constraints, maybe the way that they were trained, maybe they're, really interested in a certain aspect of biology and they're not super interested in delving into the details of something else, whatever the case may be for them. Sometimes people want things to be a little bit simpler. So our job as essentially an analysis company is not to tell doctors how to practice medicine. That would be like, Quest or LabCorp saying, well, you've got these, lipid panels. Here's what you need to do with it. Or you need to dig deeper because we saw this. That's not our job. Our job is to give doctors the tools that they need. So for our docs that want this simpler information, we have tools that give them, here's kind of the highlights. Here's the most important takeaways with some immediate action items. And if you've got a patient that is pretty healthy and maybe they don't want to dig into the weeds. Maybe it's not a Dr. Tom type of patient where they don't want to do all of that blood work. They just want, I feel healthy. Can you just make sure that there's no big red flags? That's completely up to them. If they're good with that, we will give them the tools that they need. If there's a doctor that really wants to dig into a certain area of biology, we give them tools that allow them to do that. And then how much we interact with the clinician really just depends on what they're looking for. We've got some doctors that say, hey, I've got this patient. I'm not quite sure what to make of this mutation. Can we just talk about it real quick? Yep, we can absolutely do that. We've got some doctors that, we meet with them the first time, we explain the platform, they love it, they order hundreds of tests, and they never need anything from us because they're very independent. They can dig through it on their own. They don't need any extra help with it, and everywhere in between. So it really just depends, but I think that's one of the cool things is we can work with these doctors that have completely different philosophies on medicine, and they all can find value in the test.
Has there ever I'm just thinking your obesity one was great, but is there anything that you guys have assessed that was like a 4-alarm fire that you guys were able to kind of reach out and kind of put together? And I'd also love to get into my own stuff. Just for the fact, I think it would be a lot of fun to kind of show what this real world, like the real world, and I'll screen cap it, and then I can have Jacob kind of put it up on the screen as we go through it. But I always wonder, like what's like the because I'm sure you have doctors or patients or clients or people that reach out and they're like, well, like tell us a success story. Is there ever anything that this one has ever done that you guys kind of hang your hat on?
Oh, we've got so many. I'm trying to think of what's my favorite of them. So we had a guy, this was several years ago now, who had run the New York City Marathon, ran a marathon, big athletic marathon runner guy. I think he was in like his 30s, had been very healthy to that point, had no problems. So he runs the marathon very successfully. And then he ends up sick a few weeks after that, or a few days after that, shortly after this, pretty intensive exercise. And he basically just never recovered from that, where he just didn't feel quite right. He never was able to go run a marathon again. And he had kind of bounced around between doctors and nobody really got to the bottom of it. They started saying, yeah, maybe it's in your head. I don't really know what to tell you. Like your labs all look okay. And we found for him, he actually had something called CPT2 deficiency, which can be triggered by illness and intense physical exercise. So he got that double whammy, which is probably why all of the previous times he'd run a marathon, he'd always been fine. But this was that kind of combination, and we gave him an answer, and his doctor was able to treat it, and he was able to go back to running and all of those kinds of things. So that was a super, super powerful thing for this particular individual. Where it occurred after the fact, we didn't give him an answer beforehand, but we did say, you're not crazy. I know your labs look good, but here's the actual problem. And then he was able to recover from it. So I think that's a cool one just because it was somebody that was so physically active and healthy and was completely, debilitated and not able to really function for a long time.
Wow. That's a good one. All right. Let's dig in on me. Just because I think it'll be fun for people to kind of understand this a little bit. So initially when you come to the portal, I think it's pretty fascinating. For me, I click on myself and then it comes to a navigation screen. And I'll send Jacob this so that people can kind of see it a little bit. And we'll just split screen it. So let me send, I'll send all this stuff to Jacob after. Yeah. But it gives me, risks, diet and exercise longevity plan. And then it gives you kind of different PDF reports. But what I always click on is the risks. And then I usually start with like the highest impact. And for me, right now, there's like kind of different boxes of severity. Obviously, the red, the yellow, and the green. So, red being the most severe, yellow being like moderate, and then green, I think, being positive. And then there's what's impacts where there's circles. And then there's kind of the circles are obviously in different degrees based on how, I guess you could kind of explain the impact a little bit better.
Yeah, the impact is basically scientific impact or scientific priority. So it's not necessarily the likelihood of impacting you personally. Every disease has multiple factors like we talked about. So you take somebody who's got risk for, diabetes, but they eat well, they exercise, they do all the right things. Hopefully they're never impacted by diabetes. So that's really looking at a whole bunch of different factors. It's looking at things like how common or rare a mutation is. So we don't really care what 40% of the population has. We want to look at what is specific to you as an individual. That's way more interesting. Looks at the science backing it. So we kind of mentioned that too, but an easy way to think of it is one scientific paper, not super confident, 100 scientific papers, probably more confident. So it's a little bit more nuanced than that, but that's the easiest way to think about it. And then it also looks at things like how impactful would this disease be to basically your health span if you were to have it. So you had mentioned before things like, genetic variants for eye color. That's great. That's interesting. It's not going to be on that high impact page though, because that has no bearing on your health span. Whereas something like a cancer, Alzheimer's disease, something like that is obviously way more impactful to health span. So it's going to be prioritized on there.
Yeah, my first one is age-related macular degeneration. And so that's severe. And I probably have about 90% impact. And so when I click through that one, the mutation found in the patient is different from the one reported below. However, both mutations are predicted to have the same functional effect on the protein and thus the clinical effect. So, what this tells me with the age-related macular degeneration is I probably need to go see an ophthalmologist and start being a little bit more proactive with my sight. I would go see an ophthalmologist kind of much more often because I wore glasses. I was nearsighted. I could see near, but in college, like all of a sudden I couldn't see the board. I'm sitting in these, at Berkeley, they have a lecture hall that has like 1,000 people in it. And I'm like in the back and I couldn't see the board. So I ended up getting glasses and it was fine. And then I wore contacts. And then I think it was my second year in the NFL, I got poked in the eye during a playoff game. The contact came out and the coaches are like, you need to get laser eye surgery. So I got laser eye surgery and I've been, almost like 2015 for since then for over, I think I was 25. So almost, 20 plus years that I've been this. So I just haven't necessarily, because my eyes have been fine, haven't gone seeing an ophthalmologist. So this is one of these things that I'm like, man, I probably need to go see somebody.
And what you said is exactly what I hear all the time from people where you say, oh, well, what's your healthcare team like? Who are you going to see? And they'll rattle off, I've got my nutritionist, I've got my personal trainer, I've got my internist. Like they've got this whole phenomenal team backing them. And then I say, well, so when did you go to an eye doctor last? And they're like, oh, it's probably been 10 years.
Yeah.
It's like, but your eyes are part of your health too.
Sure.
You need to do that, especially if you know that you have risk for these conditions where the earlier it's diagnosed, the better the outcome.
Yeah.
So yeah, you're spot on with this. And this is kind of what you were saying before, where what does a patient do with this? Well, you don't need to read through all of this and understand it. You just need to go see an eye doctor. And then it's on them to, understand this if they want to, or just do the tests and look for these things.
My dad, when he was probably in his late 40s, early 50s, had a detached retina and, saw the squiggly lines, went in and they did the surgery and dealt with eye issues for the rest of his life, ended up developing cataracts and they had to replace the lens. And it was like this constant thing with him, with his eyes. Yeah, like that was something I saw, and I think he blamed it on us wrestling with him or something. Like my dad was real good on like, oh, I don't know, here's the reason for all this stuff. And I'm like, maybe it's the fact that your genetics has macular degeneration and maybe your retina just randomly detached for whatever reason.
Yeah, yeah, absolutely.
The next one down is, I'm going to butcher this word, amelogenesis imperfecta. It's a junction epidemiologos bolus. And so like there's things like this where I'm like reading it and I'm like, I have no idea what these words are, but it's characterized by the fragility of skin and the mucous membranes manifested by blistering with little or no trauma. So the blistering may be severe in granular tissue, can be on the skin around the oral and nasal cavities, fingers and toes, and internally around the upper airway. So a mutation for blistering. Never had any blisters. So then you look at, so like I read this thing, I'm like, okay, I have about a 90% impact. It's a red in severity, but this is not something that has ever been much of an issue for me. I've never had anything that like, I'm not reading this thinking, oh, that makes sense now.
hmm So this particular one is, so first of all, you don't have this epidermolysis bullosa because I'm looking at you right now, you don't have it. You don't miss that type of condition. So that's a very severe disease that's onset early in life. And you can actually see on this one, it tells you under that phenotype line that the phenotype is likely to be early onset. So if you don't have it at this point, you're not developing it.
Yeah.
So it does caveat these where there's a lot of conditions that are onset early in life. If you didn't get it by age 18, you're good. Just cross it off the list.
So that's something you guys have added later. So when we originally started this, that wasn't the case. It was like you 100% have this. And now you guys have gone back and added this caveat of like, if you don't have this early onset in life, it's probably not going to affect you.
Exactly. And then for this one, the other part to this too is it gives you that amelogenesis imperfecta. So that's basically when the enamel on your teeth doesn't form correctly. So that's kind of the mild version of this. Typically for this disease, it's a recessive disease, meaning you need 2 copies of the mutation. You've only got 1 on here, which means it's pretty darn unlikely for you to have that full-on skin blistering condition. It's much more likely that you have the mild version, which is just related to, maybe speckling of the enamel on your teeth or something like that. So this is one of those where it can be kind of on a spectrum. You might have mild forms of it. You might have more severe forms of it. It really just depends on other factors. But it's flagged on here because if you did have that skin blistering condition, that's very significant. That is not something that you want to have. So the impact to health span would be very, very high if you did have this.
Yeah, but if I had had this blistering, I probably would have seen a doctor much earlier for something like this. I mean, if all of a sudden you have blistering around your nasal and mouth and in your hands, like to what I'm reading within this, I feel like I would have seen somebody more so than just suffering through.
Yeah, you definitely would have.
Yeah.
So there's cases like this where, for somebody above the age of 18 that does our testing, you're like, well, why is this on here? That's not all that interesting. But we also get kids that do our testing.
Yeah.
So
like
we've
my
had
son.
kids. Yeah. So when we have kids that do these tests, these are the things that can be much more relevant because if you know that somebody has a predisposition to this, basically at birth, and you start seeing these skin abnormalities, that's an immediate indication that you need to go seek medical attention rather than saying, well, let's see if it goes away. Maybe it's just they, got a cut here and it's healing weird or something like that. So it can kind of clue you in a bit more quickly to these more significant conditions.
The next one is muscle AMP deamylase deficiency.
Your favorite one.
Yeah, my favorite one. So for those of you guys that don't know, basically this phenotype is likely had to have early onset. If you don't have the symptom by adulthood, you're unlikely to have the symptoms. But basically, severe exercise ends up creating rhabdomyolysis, which ends up being like severe muscle pain. And when this originally popped up on my first report in 2017, it was actually a complete circle. And that caveat of like, if you don't have this early onset. And so I remember when I reached out, and I can't remember who I talked to, but it's like, he's like, oh, you 100% have this. And then I told him my history. He was like, well, I guess that one did manifest. And eventually, what the caveat he said is, in the future, we'll understand this much more as there's more research becomes available.
And you've hit the nail on the head with this. I mean, that's why we started putting in that note about the phenotype, because we used to think about genetics as being pretty Mendelian. So this is another recessive disease, but in this case, you do have the 2 copies of it. So if you were to read this out of a biology textbook, we would say, yeah, you've got this muscle AMP deaminase deficiency guaranteed because it's Mendelian. You have to. Now we know it's a little bit more nuanced than that, though. So that's that penetrance that I had mentioned earlier on in our conversation, where you have to have these 2 copies to have the disease. So in other words, everybody with this disease has 2 copies of one of these mutations. But there are people just like you that can have those 2 copies that never present with that disease. Now, why it is that you don't present with that, we still don't really have a good answer for. Fortunate for you, I imagine your career would have been a bit different if you actually were affected by this.
Yeah, well, that's what I remember. I was like, I played 10 years in the NFL. I lift weights. I've never had any of this muscle pain. And like, that was like, man, we don't understand it. But I do appreciate when you're dealing with people like yourself and other people where they're like, this is what the research say, but at the end of the day, we don't really know, because I feel like with medicine and all this, everybody wants a definitive answer, and that's just not the case. And then I actually feel like it gives you greater credibility when you say you don't know. I get really nervous with medicine where people make these definitive statements like this, everybody has this. And I'm always like, well, how can you make these, how can you make these claims? But I feel like that's just, that's what people want. So that's how they basically glean them out.
Yeah, and I'd say that's probably the biggest criticism that I get of our testing is people say, well, why isn't it black and white? Why can't you just tell me if I have this or I don't have this? And my answer is always the same. We don't have science that says that. It has to be what the science reflects. So this is a perfect example of we just don't know. I wish we knew. I'm in science because I like to figure these things out. So it drives me nuts when I have to tell somebody, yeah, I don't have a good answer for you. I'm not sure. But that's kind of the state of science. And I think that's one of the really cool things with science is we're always learning new things. It'd be really boring if we had all the answers already.
Yeah. The next one is I'm susceptible to benzene toxicity. So this is inherent recessive. Patient is susceptible due to I'm going to mess this one up.
Homozygous.
Yeah, for this mutation. Let's see. So that's the one we discussed earlier, which is, reported a case study of benzene exposed workers in China showed an increased risk of hematotoxicity in individuals with this genotype. So that's something that, like I said, I don't get gas on my hands. I don't really pour it in anymore. So DJ, who works for me, I make him do all the stuff with gas. So I feel like I'm like, God, I hope you don't have benzene toxicity either, because I'm making you do all this stuff.
I'm going to say, it sounds like he needs to do his genetic test and make sure.
Yeah. Well, yeah, he's, I've seen him huff gas and so I'm sure he'll be fine. He'll be fine. The next one is susceptible to venous
thromboembolism.
Yeah. I'm butchering these names. So I'm so much gladder that you're in here to do this. But that's the other one that I've never had any issues, but my dad had through his entire life. I mean, from his 20s.
Yeah, and so this one increases your risk for having a blood clot by roughly about a 1.5 to 2.5-ish increase in risk compared to somebody that doesn't have this. So when we talk about blood clots, that's a reasonable increase. It's not a crazy increase. It's not like it's a guarantee. There are a couple of genetic variants that are all but a guarantee that you'll have a blood clot at some point. But one of the things that we know is really helpful for reducing risk for having a blood clot is regular physical exercise and staying well hydrated. I would assume that your entire career to this point has led you to be regularly physically active and well hydrated. Yeah. So those are things that for somebody that didn't go through the things that you went through, maybe this would have been a bigger deal, but your lifestyle just naturally leads you to, really lower your risk for having a blood clot.
The newest one that just popped up that it's come up with in the last few months since I checked it is with tiptoe gait. So an abnormal gait pattern characterized by the failure of the heel to contact the floor at the onset of stance during gait. So they call that a Navajo walk is the way that the common word. And what's ironic is I've encountered a few individuals whose kids have had that.
So the tiptoe gait ones are really interesting because the first few times I looked at it, I was like, why on earth are we reporting these? Who cares if somebody walked on their toes, right? But apparently there's a lot of different neurodevelopmental conditions that include toe walking as one of the symptoms. Yep. So where this has actually been really useful is when we do these tests for kids that they're trying to figure out, does this kid have something going on that we need to address? Are they just, kind of a quirky kid, anything like that? So for something like this would basically be a way of saying, if you've got a child that walks on their toes and they have a mutation like this, it's not that they have some underlying syndrome that you need to be, seeking out some help to counsel on or anything like that. It's just that, some of these can be related to basically the stretching in the tendons in the back of the leg. So where their tendons in the back of the leg just don't stretch quite enough, and it takes some time for that heel to drop and come back down to the floor. So it seems like such a silly type of finding, but you can imagine for an anxious parent who does this test for their kids, this is the difference between, well, we need to go seek out, occupational therapy and those types of things for this child and see what's going on, to, yeah, the kid's just going to walk a little funny for now. They'll grow out of it. Not a big deal.
Yeah, it's one of the tells for autism. So
yeah, exactly.
So when parents see it, I had a client years ago whose son was a tiptoe walker, and they were going to go see an orthopedic surgeon who was effectively going to sever the Achilles tendons and then put him in boots and try to like elongate the Achilles tendons to get his feet flat. We ended up sending him to see Dr. Bueller, who's been on the podcast from the AMIT up in Kaysville, Utah. Dr. Bueller worked on him, and the kid walked out flat-footed. That kid now plays running back at a Division I football school.
Wow.
So it's funny, when he got a scholarship and he's been playing, his dad reached out to me and is like, man, we almost ended this kid's athletic future before it started by listening to a doctor where it was just a neurological thing where he was guarding. And through a series of work that Dr. Bueller did, the kid walked out flat-footed and has never had any issues since then. So that's why that one was kind of unique for me, because of a personal story. The next one was the association with bilirubin. Serum level of quantitative trait locus 1. So when I originally clicked on this, bilirubin 1 has been on there for forever, but it was actually, the severity was red and it was 100%, but we always associate bilirubin with babies. So it was kind of an interesting one.
Yeah, and this one you'll see now it's that yellow color. So now we know that these slight increases in bilirubin levels isn't really an issue for the vast majority of people. So it changed that severity to yellow to basically say, this might explain a lab value for you. Like if your bilirubin levels are always a little bit high, this is why, but it's not cause for alarm or anything like that. It's basically saying you don't need to dig deeper into this. It's not a sign of something else.
Yeah, so for kids, it's that kind of yellowish orangey color. And I think it has to do with red blood cell breakdown, but it tends to abate as the kid gets older. So, I have 3 kids, and I remember being in the hospital and seeing jaundiced kids and kids with bilirubin, and they're just kind of these different weird colors where you're like, oh man, why is that baby like that? And they're like, it all figures it out. Everything kind of levels out in the end. So then the next one is I'm susceptible to asthma and atopy. Yeah. So atopy. Yeah. So patient has a single nucleotide variation for this. And I don't think I've ever had asthma. So that one was kind of like not necessarily a non-starter, but I mean, obviously something to think about. I remember I did get sick. I did get sick in training camp one year when we were going to play the Denver Broncos in the opening game, which was at Mile High, and I was dealing with some respiratory deal, and they gave me an albuterol inhaler, and I hit it once and I felt pretty good, and then I hit it like 5 more times thinking I'd feel better, and I almost stroked out. We were up at Mile High playing in the thinner air, and then when I hit that albuterol inhaler about 5 times, all of a sudden my heart like spiked, and I thought I was pretty much going to die out on the field, and I was like, okay, I'm never going to do that again.
Yeah, so this one relates to the asthma risk, but it can also relate to allergy risk. So you have any like pollen allergies or anything like that?
I never did. Not to pollen until we moved to Texas. And let's give you a little story. So the podcast room we're in here is a barn that's on my property. And when I moved in, it was unfinished. And so I wanted to finish it. And so we ended up nailing up 3,000 square foot of cedar. And I basically lined the roof in cedar. I hired a guy to bring us all the cedar planks, but I planed with a machine all 3,000 square feet of cedar, both sides. And all that dust, I wasn't wearing a mask, so those cedar piles were everywhere. We nailed it all up, and I never had any issues. And then a couple years later, we had a huge freeze here in Texas, and it broke all these trees. So I went out, I got all these broken trees. Let me clean this thing up, and I started chainsawing these trees, not knowing that you can't mess with cedar trees in like this part of the year, which is like February, March, April, because the pollen sits on there and there's mold. So I cut down like 68 cedar trees over the course of 3 days, and it was the sickest I've ever been in my life, to the point where I was out on a hunting trip, and I remember going to bed and thinking like, I'm going to die here, and my wife's going to have to figure out how to get my body home. That's how sick I was. And I woke up and I was fine. And I went to the doctor thinking, this has to be COVID. This has to be something, like something's wrong. And he's like, you don't have anything. And I kind of explained it to him. He's like, oh, that's cedar fever. So ever since then, and that massive exposure, now I kind of have some allergies in this time of year, but it's not necessarily like crippling, but I can kind of feel it in the back of my head, in the back of my throat. Whereas I always wonder if I hadn't exposed myself to the cedar trees and maybe planting all this cedar in the barn, that I probably would have been fine.
And allergies are one of those things where it's so exposure driven. So a lot of these mutations for allergies, especially people always ask about food allergies, and those are just, there's a couple of genetic markers for it, but it really is driven by what you've been exposed to. A lot of these, you'll see with this one, it'll tell you in here that it increases IgE levels, which is basically the, kind of allergy marker that we tend to look at. And this is saying that it makes you more likely to produce an allergic reaction to certain triggers. Doesn't tell you necessarily what those triggers are. That just depends on your exposures. Oftentimes, these are these kind of inhaled allergies and things like that. So it's possible that this is contributing for why you have that kind of sensitivity. It also could just be that you were exposed to a whole bunch of it, and your body doesn't like to be exposed to an overwhelming amount of something like that.
Well, the also Texas, I mean, the allergies here are insane, like the amount of pollen, especially where we live. I had friends that lived here for about a year and ended up moving because their kids were so sick. And like, he's like, every day I got up with like a splitting headache. I like, like the symptoms that he had were not my symptoms. And so I don't know, maybe durability, who knows? And then the last, or at least the last one on my wrist, is hypertriglycemia. So
hypertriglyceridemia.
Yeah, which is high triglycerides.
Mm-hmm. Yep.
So this is one that I definitely have. But what's weird is for me, I don't eat a ton of carbohydrate. So I keep my triglycerides right around like 70 or 80 pretty consistently. Just because I know that if I can keep triglycerides low, everything else seems to look better. So I don't really eat because if I think about triglycerides, the liver can only, produce so much glucose. So if it fills it up, whatever spills out is extra triglycerides, but also regular aerobic work. And there's a bunch of interventions that you can do. But this has never been something that I've necessarily had to deal with, but it's obviously because of this. Now it's something I look at in my testing and make sure to like be very conscious of that within my own training and kind of the diet.
Mm-hmm. Yeah. And I'll be honest, you've got a pretty darn boring report, which is what we like. We never want big surprises in your genetic results. So you actually have a pretty straightforward one. Like there's nothing super remarkable in this because a lot of these are things that fortunately for you, you've just never developed. And now that you're an adult, you don't need to worry about developing them. So on the whole, you have a very nice, easy report. Oh,
well, that's good. So I was going to go kind of through some of the impact ones, but for cancer, obviously the benzene toxicity, I'm susceptible for post-chemo leukemia. There's some melanomas. I mean, obviously there's one for breast cancer, poor survival, risk for prostate cancer. So my dad ended up having prostate cancer. But I think, and this is, we talked about this yesterday on the podcast or recently on the podcast with Dr. Sabine. My dad always had constipation issues. And, she said her comment was, we've seen people that have constipation issues 20 years later develop Parkinson's, but also from those constipation issues, there's other things like, the prostate, because all of that stuff is down there. So that's I thank God I didn't inherit that from him. But yeah, there's some cardiovascular thrombosis. I'm glad that you said that it's boring because as I look at these, it's, but then I have resistance to diabetes, which is good, susceptible to insulin resistance, which is red. What was the weird one on this? Yeah, so we talked about the tiptoe gait. I have susceptibility to leprosy. I don't know if you saw that one. It's under nervous system. So the leprosy is a disease. And so I have that one, or I'm sorry, it's red, but the impact is about 10%. So, and then obviously I laughed at the schizophrenia one, but the impact is very low. And then I'm autoimmune neurological syndromes. But yeah, there's what's interesting, at least on mine, I think I don't have anything that's 100% impact.
Yeah. And that'll it changes for every person. So that's one of the biggest things that I would say when patients look at our testing, everybody's worried that they have bad DNA. and they have no context for what this might look like for somebody else. So what a lot of our clinicians do is they pull up their own report and just show it, or, another patient with the name taken off or something like that, just to give people some context for what somebody else's DNA looks like through this system. Because it's impossible to know if you don't look at these reports all the time, what is good, what is bad. So I can look at this, I look at tons of these and say, yeah, you've got a really easy one. There's nothing crazy on here. And then sometimes I'll look at somebody's report and they've got, 4 different markers for Alzheimer's disease, bunch of markers for different types of cancers, like some of those things that are a little bit harder, though not impossible to mitigate. You've got pretty straightforward ones on here. So
that's nice. Nobody's told me that.
Yeah, you get good DNA.
Good. All right. Well, thank God, because you look at these things and so I guess there is no context. I mean, obviously my wife's and my dad's and my son's going through those, but that's good because nobody really told me that. So I'm glad that I don't have anything that's too off the wall extraneous that's going to cause any issues.
No, nice and boring.
Nice. That's what I like to hear. Looking ahead, how do you see DNA based health optimization evolving, and what's next for you guys?
So a lot of it just comes down to how does the science evolve? So we focus on germline DNA, meaning the DNA that you inherit from your parents. So this is the stuff that doesn't change. We did this test the day you were born and the day you died, it would look the same. So in that space, it's really just, it's always going to be evolving. We're always going to be making new discoveries. We're always going to be refining this. The real hope is that we can kind of get to what people originally wanted, which was that slightly more deterministic type of model. So that's where things like other types of omic technologies might need to be layered on top. So maybe we start looking at epigenetic testing. So those are the DNA modifications that can occur due to different exposures. It's an area of science that's fascinating, but in my opinion, we don't really understand well enough to actually use for healthcare. But something like that in the future, maybe we can say, well, here are the genes that you inherited. Here's what you've got as kind of your base. Now let's look at something like an epigenetic modification to see, well, will you express this condition based on your current epigenetic kind of map or layover of all of these genes? So that would be an area where it would give us a little bit more certainty. Again, it's never going to be 100%, but it would give us a little bit more certainty to say, this is definitely something you need to worry about because this harmful gene is turned on and it's going to be, kind of causing some sort of pathological state. Or, yeah, you have this mutation, but we're not really super worried about it based on the lifestyle you have lived. It's not really super active. It's not something that's likely to cause problems for you. Good to know it's here, but don't be super worried about it. So that would be kind of the logical place to go next. There's other types of technologies that would be similar and kind of complementary to it. So looking at different protein expressions. So there's, these proteomic and metabolomic types of tests that can give you more of this phenotype, that kind of point in time. What is your body actually doing right now? Again, would all give additional information to this genomic study because the genomics don't change over the course of the lifetime. So it's going to be adding these kind of snapshots and times on top of it to really get a picture of what is your actual health like right now? How might it be changing? And then to track those changes over time.
So from a very kind of simplistic view, right? Obviously 2 parents come together, you have a sperm that, fertilizes an egg, and now all of a sudden you have this new being. So you're adding these 2 different types of DNA into 22,000, right? So I have 22,000, my wife has 22,000, my son has 22,000. How does the body decide which genes fit within that 22,000? Is it and the hierarchy? I mean, this has been one of the questions and looking at my son's stuff, because there's things that my dad has that I don't. There's things that my son has that my wife and I don't, that have just kind of come up. And so it's always fascinating to see, you would expect that my son would have exactly what I have or my wife has.
So everybody has the same 22,000 genes. What changes are the different letters within those genes. So if you think about your entire genome as a big puzzle, right? Imagine it's a puzzle with 22,000 pieces in it. And all of it's going to come together to form a picture, but everybody's picture looks a little bit different. Each of those puzzle pieces might have different colors on it or a different pattern or something like that. So that's really what we're looking at. That's the part that makes us unique, is what version of each of those puzzle pieces did we inherit? And it's not just, there's 5 different options. There might be thousands of different options because that puzzle piece is, pretty big size. There's a lot of different parts that can change. So when we look at these genetic variants, what we're really looking at is we're taking the gene, that puzzle piece, and then we're really zooming in on a different part of the puzzle piece to say, well, what color do you have at this location versus that location? Or, what's the pattern here? And that's what you inherit from your parents. So if we took your puzzle, your wife's puzzle, we would see a hybrid form of that in your kids, where you'd have some puzzle pieces that look maybe exactly the same as yours, some that look exactly the same as your wife's, some that are kind of a hybrid between the two, and so on and so forth. So that's the basic idea for how these things are passed on, right? Everybody's going to get this unique puzzle based on what their parents gave them. And in theory, it should be a 50-50 chance that each genetic marker that you have is passed on to each of your children. So that's kind of the biology textbook answer, right? Is it's 50-50 exactly. There's some cases that it's not exactly 50-50. So a good example of this is something called linkage disequilibrium, which is a really fancy way of saying mutations that are stuck together. So in other words, 2 puzzle pieces that are next to each other, maybe they're glued a little bit together and they're more likely to be inherited together. So rather than them being completely independent, you might get that chunk of puzzle pieces together from one parent. So that's the way that these are going to be passed on. You can't typically just kind of manifest a new puzzle piece or change the puzzle piece so it doesn't match one of your parents. There's some exceptions to that. So we call those de novo mutations, meaning they just arise randomly. Those do happen. Not to say that they're uncommon, but most of them, everybody has them, but most of them are very benign things we don't even notice because it doesn't cause any sort of pathological state or anything like that. But that's the idea with this, is it's going to pass these things on. They should be 50-50. Some things can be connected together, and then some things we just don't fully understand why certain things are more likely to be passed on than others. The biology there gets very complex very quickly.
Yeah. No, I mean, there's nothing simple about this stuff. And I think what we've tried to, hammer out here is that there is no definitive answer. All you can hope to do is submit your DNA, get a report, and then watch it evolve over a number of years. And I think that's what was most exciting for me is, and I, like I said earlier in the podcast, I get very nervous when people give me definitive answers, especially when it comes to health. Like, you have to train this way, you have to eat this way. I mean, one of the things which was fascinating with Dr. Sabine and why I originally reached out to her was I had theories on what I viewed as like the perfect human diet. And you'll hear this, like, this is how, and you hear, like I said, biohackers people, everybody has to eat this way. This is the diet. Like, if you want to live forever, this is how you eat. And that's just not the case. It's the diet that you're most adapted to eat that allows you the best outcome. And the only way you know that is you got to get your stool test done. And you have to test it, and you have to see what the markers are on the microbes. And it's based upon genetics, geography, and opportunity, and where you are, and like all these different, endless amount of factors to kind of drive this. But she can look at it and say, what you're eating is benefiting you, or what you're eating is not benefiting you, and you have to make a change. I think what's fascinating on this is, these are the genes that you have when you're born, and these are the ones that you're going to have when you die. And I do look forward to the day where all of a sudden now you guys are able to show gene expression and kind of this thing evolves. I think it'll be more and more fascinating. And I think like all of these just go to work within like, what's your diet, what's your lifestyle, where you live, what's the environment, and all these other, key factors. And hopefully at some point in the future, we can kind of create a kind of a portrait or like a roadmap of like, here's the decisions you need to make to live, your best existence.
Yeah. I think the biggest thing with that is there's never going to be one right answer for anybody, for anything. There's no best diet for anyone. We can look at genetics and we can say, well, we know that people that eat a diet that's more like this with this genetic marker have lower cholesterol or, lower body weight, better muscle mass, whatever the case may be. But there's not one right answer. It just depends. Maybe the perfect diet includes foods that you hate or you're allergic to. Well, then it's not the perfect diet. there's so many nuances to everything. And I think that's really the fun part of science and medicine is it's not one size fits all. And even with that, there's not one answer for each person. It just is going to depend. I think the microbiome stuff is really interesting too, because one of the big things that we've seen is the more diverse of a diet that you eat, generally the healthier you are. There's exceptions to it, but you have a lot of bacteria in your gut. We need to feed a lot of different populations of them. So if you just eat one type of diet, it's pretty darn unlikely that you're going to have a nice, diverse gut microbiome that's able to support a functional immune system and all of these other, the neurotransmitter balances in the brain and all of that. So it all connects. Science is complex, but that doesn't mean that there aren't pieces that we have pretty decent clarity on that can help guide you towards making the right decisions for your health.
That was a actual observation that Dr. Tom made, because I always ask him, like, with all this, all this research and all this stuff, like, are there any like interesting definitive statements you could make? And that was the people that eat the most diverse diet tend to be the healthiest individuals. I had a doctor, Dr. Nicholas Romanov, who invented the pose method, who was a Russian sports scientist many years ago on the podcast, and like in a kind of a back room discussion. He was saying that, like, in Russia, when they brought in all the coaches that had trained all the professional athletes and like Olympians, and they basically brought them into this big conference, and they wanted like all their research, everything, and they were going to kind of like put it together and see if they could come up with like a perfect training program for these individuals. And after like 10 years and submitting all these data points, they finally had to get up and produce their results. And the guy gets up there and kind of nervously goes, the only thing we could glean from this was that the fastest people in the world ran the fastest in training, and the strongest people lifted the heaviest weights. And so he he kind of dropped this bomb on me, and I was like, didn't necessarily know what to think about it. But then as I've grown older and, kind of gone down this road much more, it realizes that, the healthiest people are the ones that tend to eat the most diverse diet, that tend to sleep the best, that train regularly. And you can kind of go through these factors that, like, when you see this applied to people, it's very rare that you see somebody who's unhealthy that fits within these kind of different lifestyle modalities. And,
absolutely.
And then, so like with the diet stuff, it's even more fascinating for the fact that there's a lot of like different, like kind of not necessarily genetic, but, we're tied to certain environments. So there was evolutionary biologist named Dr. Michael Rose, who I think he teaches at UC Irvine. He gave a talk at the Ancestral Health Symposium the year after I spoke. And his research basically went back to, like, as you age after the age of 40, you have to return back to your ancestral diet. That they've observed this in all these different, he actually did a test on fruit flies, but they found that, like, what your ancestral diet is, and that was an interesting observation that Dr. Sabine just made. She's like, there's definitely a diet that's kind of tied to where you're from, basically, not only within the genetics, but like within the microbiome, because there's different bacteria associated, or microbes that are associated with different parts of the world, where she's like, I can tell you where you're from, or more importantly, like, what part of the world, has influenced you. And, like if you look at, people from Brazil and the Amazon, they have a completely different microbiome than people from the Middle East. So to say that you take those people, put them there, give them a different diet and a different set of environments, like whether or not they're healthy or not, like that's up to interpretation, or, how well and how adapted they are and how kind of resilient they become. So it's fascinating. And I feel like we're on the cusp of it.
Definitely. Yeah. I'm excited about all of these other advances and other things that we can kind of layer on, because it's all of it adds new information. We're never going to have a perfect answer, but if you can improve health by 1 or 2% by changing a diet, changing an exercise program, something like that, that's really what we're here for.
Awesome. If people are interested in learning more and they want to, sign up for the, I don't know, it's not necessarily a service, but kind of invest in their health and invest in New Amsterdam Genomics so that they can get their genetic sequencing, what's the best way to do it?
So they can go to our website, nagenomics.com. The best thing, though, is this is a doctor-ordered test, so you've got to talk to your doctor about it. If it's a patient that's interested in doing the test and maybe they don't have a doctor that they think is going to be willing to help out with that, they're always welcome to reach out to us, and we can try to connect them with somebody in their area if we've got somebody. If it's a doctor that's interested, we can do web demos and show you what the platform looks like so you can decide if this is something that's going to be really helpful for your patients. But the first step is really go to the website and just reach out to us with whatever your question is, whatever we can help you with.
Awesome. Well, thanks for coming on Power Athlete Radio, and I appreciate the information. And thanks for going over and telling me that I'm very unremarkable. I do appreciate that one.
Of course. Anytime.
Cool. Thanks for tuning in. See ya. Hey there, Power Athlete Nation. Big shout out to all the heavy hitters who stuck around till the final whistle. If you've been soaking in the knowledge bombs and epic tales we've been dropping for free, here's your chance to be a game changer. Swing by klfi.com/powerathlete and toss a few bucks our way to keep the podcast fueled and firing on all cylinders. That's ko-fi.com/powerathlete. Your support makes a difference. See ya.